All right, so thank you for attending. We're just going to talk about session 4, which is talking about different random number distributions that you can do with Jupyter Notebook. So let's take a look. Let's open up Jupyter Notebook. And now that we have Jupyter Notebook opened, let's start a new Python file. So we're going to have a couple. We're going to show you. I'm going to show you a couple of different types of distributions that you can do. So, for example, let's start with random normal distribution first. And so again, top cell. We're going to import the random library, and then we'll also import matplotlib. As this library is quite useful when you want to just plot some data. So I'm going to hit Shift Enter here to start. So as far as the random number distribution, we're going to take a look at the documentation. So if we go Python random normal. Could use the NumPy distribution, but if we just use the random here, we'll see here with the random function, there's lots of different things that you can use. So let's just take that link and let's go. So what did we say? We wanted random normal distribution, and I'm going to just copy that file in, and let's take a look at the normal. So here we see basically with random normal distribution, we need a mu and a sigma value. So that's mu and sigma, and we'll just take that line there. So mu is the mean, while sigma is your standard deviation. So that's not too bad as far as how to go and create that. So let's start with, let's create an empty list to start with. So we'll call that num, just list empty. And then let's do the mean. Let's do a mean of 0 and a sigma or standard deviation value of 1. Now, as well, just so that you're able to get the same, numbers that I get randomly, we do have something that's called the seed value. So basically, what we can do is we can load up a similar seed value, and then that will give us the ability to have the same numbers populated. So seed, just look here. Okay, .seed, here we go. So with the random.seed, basically we just have to pass random.seed and then the number. So let me just grab that URL. We'll link that there, and then we'll call the random.seed, and you can use any number that you want. So for the random value, when you're actually generating your distribution, it uses kind of the timestamp associated with your, like, when you ran it. So for me, like if I'm running it now at 3 p.m. And then I run it at 3:05 p.m., I'll get a different number based on that. But because I'm using the seed number 42, if I did this, you did this, your neighbor did 42, we'll all get the same values. So, and then let's create a random list, and we'll use a for loop. So in this case, we'll do, say, for I in, and I don't know, let's make 100 values. So we'll do 100, and so we'll call it temp value. And this temp value, we'll use that random.normal variant. And since we had already called mu our average of 0 and sigma of 1, it'll populate that in there. and then all we have to do is use the append function um, to add each temp value, and then we need to add it into our list. So in that case, so run this once, create a temp value, add it to the num list, run it again, run it again, run it again, run it 100 times, and then you're done. So let's shift enter. And then let's just check the length of num just to make sure. Yeah, so we're getting 100. So we know we have a 100 list there. So check for 100 entries in the list. Okay. Now in a case like this, you could check within the num list itself. Say, there's a specific number. So this would be the 6th position within the list. And so your 6th position should be the same as my 6th position if you're using that random seed value of 32. So yeah, so that's basically, so we've got it all created out. So if I was to just go num, we can see all our numbers there. You don't have to look at them all. We can just look at one if we wanted. So now what we can do as well is we can use that the matplotlib, and we could plot it and take a look at what those what that data looks like. So so let's see, matplotlib, and there's a cheat sheet to the right there. Yeah, that looks like that. So that's good. Maybe we'll use this cheat sheet because what we're going to want to do is we can plot, say, a histogram. So if I was to go in here and see, yeah, so in the advanced plots histogram, we pass the value of x. So in our case, it'll be that num value, and then we could create a bin size. So let's use that. So create histogram with matplotlib, and there's the cheat sheet. And then what did it say? So, well, we imported matplotlib.pyplot as plt. So plt dot, and then we said it was hist, right? HIST, yeah. So HIST, and then open bracket, and then pass your x value. So in our case, that'll be the num distribution we just created. So if I hit shift enter, you can see it creates some arrays, and then it kind of creates a bit of a, the numbers look like they go from plus, like a standard deviation of +2 to -2, and you can kind of see it from there. Now, I mean, you could bin this. You could specify your bin numbers if you want as well. Maybe we don't want 100 anymore. Maybe we want 1,000 or 10,000. We'll run that one again. Now we've got 10,000 values. Our fifth out, or the 5th index, or the 6th position in the list, is still the same. And now if we run this, it's starting to look more like that normal distribution bell curve. And it looks like we've went from almost +4 to -4 as well. So yeah, that's kind of a different way that you can go through and check that. That's kind of using the random normal distribution. Now, what you could do is, yeah, so that's random normal. Let's save that, close that off, and then let's start a new one as well. So we could create, so we could do the exponential distribution. So same as we just did with our last one, we imported random. Actually, let's name this random exponential distribution. Okay, import random, and then we wanted to import that matplotlib.pyplot as plt. Okay, oh, there we go. Matplotlib as pyplot. There we go. Okay, and then let's take a look again at the random number distribution. And in this case, we wanted random We wanted random dot exponential. Yeah, we want this one. So it looks like in this case, all we really need is that lambda value. So random exponential distribution, and we said it was this with the lambda. And yeah, if I click this, we can put that URL in there. And again, similar to what we did last time, let's create that empty list. And we'll use that num with the square brackets. And in this case, instead of, we'll use lambda, well, we'll call it lambda. Looks like it doesn't like, if I call lambda, it thinks that's a specific number. So lambda of what, 1.5. Okay, we'll do set the seed value again. And we'll do seed dot random dot seed of 42. And that's fine. And same as before, we'll do that for I in range of 100. We want, we'll do that temp value. And it's going to be the temp value is this random.exponential. And then we want to do the append. And this kind, we're appending it into that. Take the temp value and then we add it into, what do we call it, num? There. And shift enter. Now, again, we can check the length of the list. And that's length of num. See, we get 100. And we can do that, we can create that histogram again. So create histogram, which was plt.plot, and we just had to pass that num val. So obviously, oh, sorry, not plot. That's just plotting all the specific numbers that were randomly created. We wanted hist, which was the histogram. So this takes it and bends it up based on, so we can kind of see we're getting that exponential curve. It's not the normal curve that we were expecting last time. And again, if we want to see it a little more clear, we can put maybe 10,000 entries in there, and we see it's like quite consistent that a lot of values are definitely between that 0 and 1 value. So yeah, that's exponential. And then I guess the last one we can take a look at was the uniform distribution. So with uniform, so let's save this, close, and new Python, and we'll do random uniform distribution. Again, the same as last time, import random, import matplotlib.pyplot as plt. We're good. And then we want what, random uniform distribution. Let's take a look at the documentation, random.uniform. So basically, with uniform, you pass A and B values, which is, always create a number between, say, 0 and 1, whatever basically you want it to show up as. So we'll do that. And let's grab that link. Okay, again, let's do that empty list. Empty list, num, square brackets. Now in this case, we've got an A value, which, I don't know, let's say 0, B, and maybe 10. And, okay, set the seed value. Just keep it at 42. And then, same as last time, for I in range 100. Create that temp value. And we're going to use that, what is that, random uniform A and B, which is, create these random numbers between 0 and 10 for us. And then num dot append, and that's our temp value. Now, the one thing, let's run that, and the one thing that will happen is if you were to check, so say you checked num, I don't know, 6, you can see that this number is actually, it's between 0 and 10, but it isn't actually an integer. So at any time, what you could do is you could, throw an integer in front of us and shift run it, and then it'll always it'll always give you a number basically between 1 and 9 would be that, because it's very unlikely that you're going to get a 10 as your value. So so yeah, that's if you wanted to create a list of integers or true false, 0 1, you can make a true false this way too. So if I kept that back, now you're getting that 8.9 again. So okay, and let's just check the length just to be consistent. Length of num, so you get 100, and then we could chart it again. So create histogram, which is plt.hist at with num. So yeah, you can kind of see here that it's not, you're getting, because we have a low number of 100, looks like we've got more like 3s more than anything else. But if we kind of pump that up to 10,000 and ran it again, you can see you're getting pretty consistent with this pretty even uniform distribution amongst the numbers that we had selected. So yeah, that's the different types of uniform distribution. But another way that you can use the uniform distribution is actually, so say you had, I don't know, say you wanted to just do, say, like a random assignment, so like of certain values. So say you had a car list equals and Toyota matrix, Honda Civic, Dodge Ram, and let's add a fourth one, Nissan Sentra. So in this case, we've got our car list. We can kind of see, if I've got a car list and I've got a value of, say, 0, that's always going to give me the first in the distribution list. If I go 0, 1, 2, 3, that's the first index. Car underscore list of 3, like we said, that's the last index. So that'll be your Nissan Sentra. But you can actually use the random uniform distribution to populate a number for that. So for example, let's take this. Basically, if we were to call, so what do we say, random, well, here, let's throw this in here, using random uniform distribution for sampling. So in a case like this, you could use that random uniform. So in a case like that, 0. And now what we could do instead is, instead of A being 0, or A could still be 0, and then B can actually be 3, or in this case, what we would actually do is take the car list and then take the length of that value. So in that case, we know it's 4, because 1, 2, 3, 4, and I always subtract 1 from it just because it's inclusive. So basically, in this case, we would have 0, and then in this case, it would be 3. So create a random uniform distribution between 0 and 3. And then what you could do is we'd want to just either round that probably to the just to the 0. So you could also do integer. That's another option too. But if you did that, you kind of because I'm not using a seed, it's gonna kind of keep populating different numbers there. 1, 2, 3, and you could do something like, yeah. So random underscore assignment, and then you could just and then we would use this basically to fill in the number that's associated with the car list. So car underscore list, and it's going to just pick the index for you. So in a case like this, run this, Toyota Matrix, Nissan Sentra, Dodge Ram. And it's just going through, and it's picking, in our case, a number between 0, 1, 2, or 3. So yeah, so that's kind of two useful methods for random uniform distribution. Also looked at exponential distribution as well as normal distribution. So great. So yeah, as well, take a look at the documentation. That page, random.html and documentation. There are lots of other types of distributions that you'll be using as well, but those are some of the most common. Great. Thank you and have a great day.